Hi there, Mason Coon, and today we're going to be talking about spectroscopy.
You started.
Yeah.
Okay. So next we move into IR, which you can see is breaking down into zones. We're looking for the transmittance of a lower level. There are 5 zones in it, and also the fingerprint region. You don't have to worry about the fingerprint region unless you absolutely want to do it. So I'm going to break down the first zone. As you can see, there's no dip down towards the 0, so I could qualify for nothing. Second zone, you can see there's a very long shape, kind of looks like a beard. This could either be an alkane or a carboxylic acid, and the beard usually qualifies for a carboxylic acid, so I'm going to circle that because there will most likely be one in the structure of the formula. So we next move into zone 3. You can see there's nothing again, so I'll write that down. Zone 4, we get a little bit of a shape. This qualifies for a lot of things: aldehyde, ketone, ester, or even a carbonyl. Main focus of this one is going to be a carbonyl, so I'll write that one down, circle it. And then in the 5th region, there's a couple going down here. The main one I found of this is aromatics, and with the number of carbon atoms in this molecule, I'm fairly certain that there will be an aromatic in this molecule. So next we move into IR, which you can see is breaking down into zones. We're looking for the transmittance of a lower level. There are 5 zones in it, and also the fingerprint region. You don't have to worry about the fingerprint region unless you absolutely want to do it. So I'm going to break down the first zone. As you can see, there's no dip down towards the 0, so I could qualify for nothing. Second zone, you can see there's a very long shape, kind of looks like a beard. This could either be an alkane or a carboxylic acid, and the beard usually qualifies for a carboxylic acid, so I'm going to circle that because there will most likely be one in the structure of the formula. So we next move into zone 3. You can see there's nothing again, so I'll write that down. Zone 4, we get a little bit of a shape. This qualifies for a lot of things: aldehyde, ketone, ester, or even a carbonyl. Main focus of this one is going to be a carbonyl, so I'll write that one down, circle it. And then in the 5th region, there's a couple going down here. The main one I found of this is aromatics, and with the number of carbon atoms in this molecule, I'm fairly certain that there will be an aromatic in this molecule. So next we move into the proton NMR of the molecule. As you can see, I've drawn it out. You can see it's a very large molecule. We do have the aromatic and also the carboxylic acids featured in here. So now as we move down, I'm going to work this left to right for you. This first line right here, this singlet, is coming in at 7.2, and that gives a strong aromatic signal, so I'll write that down. I'll also circle, I labeled it A, and I'll circle the 2 hydrogens that it is representing right here. I'll label them as well. Both of these are A. Work to this next one. It's just 7.0, and it's also qualified for aromatic. There are 2 other hydrogens on this aromatic that B will be covering. I'll circle them now and label them. The next line doesn't come until 3.7, and that is qualifying for either alcohol halide, or an ether. And you can see that it is actually going to come up over here on this hydrogen right here. I'll label that C. Also need to fill in to show you the total mass of or total products of the hydrogens. So I'll write 2 here for the 7.2. I'll write another 2 here for the 7.0, and then for the 3.7, I'll put 1. Next we'll move down to 2.4 right here. You can see that on this chart it applies for a secondary alkyl, which right here it's featured in a secondary alkyl, so I'll circle that whole molecule, but it will only reference to the H's. Label that D. And then again, I'll write a number 2 down here. Next we move to 1.8, and on the chart it is labeled as a tertiary alkyl, so I'll write that down. As you can see, right here there's tertiary alkyl, so I'll circle that for you and label it F. And as you can see, it applies to 3 hydrogen, so I'll write 3 above this line. Next line is at 1.4, and here it applies for a primary alkyl, so I'll write that down. Actually, I need to label this E. Don't know my alphabet. So actually, this is F. Sorry. The E actually applies over here. This is the tertiary alkyl. This is the primary alkyl because it is only attached to 1 carbon. This one is attached to 3. So this one will be E. It'll be 1 actually. And then we move over to the 1.4, which is a primary alkyl. It's only attached to 1 carbon, 3 hydrogen. I'll write down 3 for that. Then on the last one, there's it applies for a primary alkyl as well. So I'll write that down. As you can see, you have 2 left here, so I'll circle both of them, label it G. And you can count up the total hydrogens, it comes up to 6. Now if we add these up, it's actually equal to 17. And you might be wondering why we're 1 short. Well, actually on this alcohol group over here, this hydrogen actually gets cut off, called labile. It gets cut off because it's broken down when the molecule is subject to the NMR testing. So then you're stuck at 17. So the last step of spectroscopy is looking into the carbon NMR, which will be focusing on the carbon atoms in the molecule. So first off, we're going to start working it right to left. This first line here comes up at 18 parts per million. It's actually a primary alkyl. So I labeled it 10 for you. We look up at the molecule. It's primary alkyl right here. Label it 10. Next down, move to the 22 parts per million. Large line here. It's also a primary alkyl. And there's 2 of them on this. One over here and one over here, because it's farthest away from the most electronegative atom. Next is to move to 30, which is actually a tertiary alkyl. As you can see right here, it's attached to 3 carbons and 1 hydrogen, making it tertiary. Next, move into 45, which actually has 2 of them on here. Represents a tertiary alkyl and a secondary alkyl. 7 is the tertiary alkyl, right here, attached to 3 different carbons. And then 6 is secondary alkyl, attached to 2 different carbons and 2 hydrogens. And the next 4 numbers, 127, 129, 137, and 140, all represent an aromatic carbon. The first 127 and 129 both have 2 carbons they represent an aromatic. 5 being these 2 because it's farthest away from electronegative, and then as you move down, it'll be closer, so 4, and then 3. And then the 2 actually comes over here because the aromatic pulls charges, so making this a 2. And then on the last one, 181 represents carboxylic acid, which we know to be very electronegative with 2 oxygens on it. That is labeled number 1 because it is the most electronegative.
And that about sums it up for spectroscopy. I'm Mason Coon. Thank you for watching.